Radio Shack? Okay.
What?
The 80s called.
Welcome to the CoCo Nation, the world's first live and interactive talk show featuring the Tandy color computer and its hardware cousins.
Main here and see what we get. Hey, look at
Yeah,
that.
there we go. It had the no camera earlier.
I got it. Okay. Yeah. It's because, like I said, it turned off. So,
Okay. Oh, yuck. I better close that until I make my bed.
oh, well, my CPU usage under 10%. So, whatever I selected seems to be working as long as we're streaming. So, hopefully, it looks good. Hey there. Hey, I'm new at this. So, I'm making lots of mistakes. But anyway, so this is CoCoTECH, hopefully number 2, unless I miscounted, which could happen. And I have here with me Paul Fiscarelli and Paul Thayer, otherwise known as Redbeard. And Paul Fiscarelli has this cool little tool. It's called the CoCo Sprite Compiler. Is that right? Paul? Are you muted, Paul?
You're on mute, Paul.
Yeah, will you just get the heck out of here?
How about now? Can you hear me now?
Yes. So your product's
Testing
called
1, 2.
Yeah, we can hear you.
Yeah.
CoCo-
So you're right, Mark. It's called CoCo Sprite Compiler, CoCo
Excellent.
SC for short.
Okay, excellent. So brief intro of who you are, and some people know you, but others don't. So for posterity, introduce yourself briefly, and then let's talk about your product.
Sounds good. So Paul Fiscarelli, for those that don't know me, been involved in the community for quite some time. Actually, I never got out of retro computing. I kind of always had a CoCo set up, even through the late 80s, early 90s into the 2000s. Became much more involved probably in the last 10 years or so as the community started to grow. But got my first CoCo for Christmas back in 1982. And one of the first things I did was took it apart and figured out how it worked. And I was really intrigued by the hardware. Started coding from there and just kind of took off and launched my career in technology. And so been working on this Sprite compiler for the last 2 or 3 years. A lot of guidance from Paul Thayer, who's joining us on this call, as well as Simon Jonason, as far as what kind of features and functionality they would like. Paul, being an avid game developer, was instrumental in supplying me with a lot of info on what the tool should do and how to optimize it. So it's still kind of an alpha release. Still working on it, kind of continuous work in progress. So looking to make it more widely available to folks in the community and for them to try it and provide feedback. Let me know what they like and, do some bug testing on it. If you do find bugs, just let me know and hopefully I can improve on it and make it something of value for you in your game development. So yeah, that's me in a nutshell.
So does that mean it's my turn?
Yeah, why don't you do a quick introduction there,
Okay,
Paul?
All right, cool. I wasn't the one with the product this time, but so I didn't know if I was going to introduce myself. But yeah, I'm Paul Thayer. I've been active in the community for a while. I can't tell you dates like Paul can. I got a CoCo back in the 80s, I'm pretty sure we started with a CoCo 2. Eventually we got a CoCo 3. I started doing basic when I was like 5. I don't have a career in computers. So yeah, but I've been a video game developer as a hobby for basically ever since I had my first CoCo. And a few years ago, Paul and Simon and I talked about some projects or whatever, and Paul started creating the sprite compiler, which I have been using basically since its infancy for the development of any of my Color Computer 3 games. Yeah, I mean, it's specifically for the CoCo 3 at this point.
That's right. Yep.
Which we would probably discuss later. But yeah, so that's me in a nutshell. Is I try to write games for the Color Computer 3 and release them on itch.io.
Yeah. No, thanks, Paul. Yeah, and I appreciate all the help that you've given me and all the feedback that you've given me to get the utilities to where it is today. As Paul mentioned, it is only for the CoCo 3. And the reason why is because it does it's specifically geared towards 4 bits per pixel. So the 16 color modes on the CoCo 3, anywheres from 40 byte wide resolution to the 256 byte width if you're doing HVEN. But the more popular modes are 160 and 128 byte modes. So the 256 by whatever, 192, 200, 224, or the 320 modes as well. So yeah, it's geared towards the Color Computer 3. It's I've kind of built some functionality into it where I anticipate being able to support 2-bit per pixel modes. So that would lend well for the CoCo 2, obviously, or the higher resolution mode on the 640 mode on the Color Computer 3. So we'll see if that happens. I've found it kind of challenging to find the time that I put into it so far to get it to the point where it is, and I don't want to add any feature creep or promise anything that we're not going to be able to deliver. But if you're into the 4-bit per pixel development on the CoCo 3, I think you'll find this tool extremely useful. So to get started, what I've got here is just a brief presentation on how graphics work on the Color Computer 3, or the traditional method of putting graphics onto the Color Computer 3. And I thought it would serve as a good intro for getting into the sprite compiler. So I'm going to go ahead and share my screen here. All right, can you guys see that okay?
Looks fantastic.
Fantastic. Looks like I got the date right and spelled your name right and everything there. All right, so let's see here. So quick topic as a discussion. What is a sprite? How do we draw sprites on the screen using the blitter method? And then also what a compiled sprite is. I'm not going to do death by PowerPoint. There's only a few slides here. We're going to do a lot of hands-on for you guys to see what the process is. So what is a sprite first and foremost? And I know there's been some debate about this lately in the CoCo community. But basically it's in computer graphics terms, 2-dimensional bitmap array that is basically integrated into the graphics screen. And it's most often to do with a 2D game. Originally, the term sprite was referred to a fixed size object that was composited together, typically by hardware with a background. But the use of that term has since become more general to represent any 2-bit 2D bitmap array that can be drawn on a graphic screen. The term originally came about through Texas Instruments back in the 70s when they had their Alto system. Different systems adopted different methods of doing the hardware sprites. Atari, for instance, used the player missile graphics. Commodore adopted, the sprite method. They always had, the luxury of having a hardware sprite engine. NES, had their object files and whatnot. So many different platforms had the luxury of having hardware sprites. CoCo, unfortunately, never did. So we always had to do it with the CPU. Fortunately, we've always had an extremely powerful CPU. So we've always kind of risen to the challenge. So how do we draw a sprite on the CoCo 3? So the traditional method of drawing a sprite is to kind of break it up into a byte array. And the byte array is on the left-hand side, you can see where we have a Gallica spaceship, and you can tell that it's 7 bytes wide, or 8 bytes wide by 16 scan lines tall. Each byte, since we're doing 4 bits per pixel, each byte can represent 2 separate pixels. So using a color palette that's displayed in the middle, where we have the color palette slot that shows the 16 color palette slots on the CoCo 3, it's going 0 through F, and we do hexadecimal. It's just easier to annotate and to display the data output. But 0 is the color black, 1 is the color white, 2 is the color palette slot 2 is red, and color palette slot 3 is blue. It's only a 4-color sprite, so we don't have any other colors in the remaining slots. But you can see on the left-hand side where we've got the representation of the ship. On the right-hand side is the data statement representation. And you can see, for instance, this particular byte here located at column 7, row 8 on the data grid, it's represented as 2, 0. So 2 being the color red, 0 being the color black, and it represents that 1 byte. So what we would typically do is have an algorithm on the CoCo that would take and blit these individual bytes to the graphic screen. It would iterate through 2 series of loops, 1 loop doing the horizontal row, and then the other loop would be doing the column. And the code would look something like this. And this, I just quickly wrote this within the last hour just to kind of demonstrate it. It's probably not the most efficient, but basically it shows where we've got, we're loading in the X size of the sprite in bytes, the Y size of the sprite in scan lines. And then what we do is we store those 2 values. They're off screen, but I've got 2 memory bytes reserved for each one of those values. And there's just basically a Y loop and an X loop where we just step through the array and blit these graphics to the screen. And I can show you an example of what that looks like. So I'll bring up, I'm off screen here, but one second.
So while Paul's getting that ready, I'm just going to comment on that real quick. So in preparation for drawing in this method of blitting, you will have to state the horizontal and vertical size of your sprite in order to draw it correctly by going through the array where the data is stored and then taking the bytes from that array and basically copying them and maybe even mixing them with what's on the background. I think in your code that you had there, you're just straight up taking the bytes and putting them onto the video memory, but
that's correct, Paul. And what we're not taking into consideration here is any overhead that would be needed to handle transparency or image transparency or image masking, which requires a bit more overhead.
Yep.
So again, here's the code. So basically it shows up at the top where we've got our sprite X size is 8 bytes wide, sprite Y size scan lines is 16. And then our width is 160 bytes. So we're doing the 320 by 200 by 16 graphics mode to draw this sprite. So I'll bring And what this is actually doing is it looks like it's slow, but it's, I've got a 1/10 of a second delay in between each pixel or each byte draw, just so you can see what it's actually doing. So one thing I want to do real quick, just as a test, is I'm going to take that, actually, so we're going to save that and I'm going to run it again. We'll do full speed. So what I'm going to do is bring up one of the new features of VCC, which is the execution trace, where we can trace through the code and we can actually see how many cycles this takes to run. So I'm going to go ahead and reset this, minimize it. I need to take a look at the, that's not the output I want.
Oh, I'm sorry, I was on mute. And again, when we're looking at cycle counts on this, guys, keep in mind, we're not even doing any kind of transparencies. So there's no masking or mixing. This is just straight up taking bytes from one area and copying them to another.
Exactly it. So what I'm doing is I'm just putting in on the left-hand side, we see that we've got where this entry point is to this plot sprite routine. And then our exit point is down here at E78. So I'm going to add those two values. I've got E50 as the start. And we're going to do E78 as the end. We'll enable the trace. And then I'm going to just execute the code again. And it drew it on the screen, happened extremely fast that time. And what we can, this might be kind of hard to see. I can't change the font on here, unfortunately. But what it does is it shows us stepping through the loop and how many times it actually goes through the loop. So we can scroll all the way down to the bottom here. Did we get the full thing? We did. So down here at the bottom, the second column over is showing us took 3,831 cycles to draw that one graphic, doing the blit method. So we'll make a note of that. 3,831. If somebody wants to write that down,
I'm on.
We'll
And that
Recording in
was
progress.
3,831.
That's correct. So yeah, there's the frame buffer again that we were referencing in the code, and it's basically what we had copied out of what the compiler had created.
So how much RAM did we just use up though? Right.
How much RAM?
Other thing. So that's like that's 8 by 16 bytes, right?
Yeah. So the 8 by 16. So what is that? 80, 128?
Yeah.
Yep, 128. So plus the code that it takes to draw it, but that's not big. I mean, we've maybe got about 30 bytes of overhead there, if that.
Yep. So
so maybe 160 bytes total. So we'll use those as good reference points. So that gives you kind of a sense as to, how to draw graphics on the screen in a traditional method. So what is a compiled sprite? And this was kind of my definition of it. I couldn't find a really good definition. So basically, compiled sprite is an assembly language or machine code representation of a 2D bitmap array using optimization techniques to render the sprite object on the graphics display as efficiently as possible. So to put plainly, on the right-hand side, what we're doing is we're actually just cherry picking byte values, the actual graphics data from the bitmap image, and using assembly code to translate that into assembly code statements to draw those bytes directly on the screen. Instead of going through and doing every single byte, we have the ability to step over any of our blank space, our background space. And one of the things that's nice about it is that gives us the effect of having transparency and masking built right into the sprite. So there's overhead associated with that, as Paul's going to show you in just a minute. So I'm going to turn it over to him, because what he's going to do is give us a live demonstration of actually how to hand code a compiled sprite, taking a bitmap image. So we'll go ahead and do the live demo and turn over the sharing to you, Paul. I'll stop sharing on my end.
Yeah, cool. I didn't prepare any of my screens to be shared right now. So I have to briefly set that up here. And
Do
for
you
some
need a minute?
reason, I just can't get the Zoom to move out of the way. I might not be the best person to do a live demo. I'm just joking, but yeah, like I can't get my Zoom to not minimize, but like just kind of not be full screen here. Okay, that helped. Cool. Awesome. Almost ready. Sorry about that.
All right, I'm going to go ahead and stop sharing.
Okay.
While Paul's pulling that up, do we have any questions or anything yet, Mark, or any?
Mark's on mute and walking away.
Oh, he's just checking the chat log, I think.
Oh, okay.
Now, the problem is I can mute my computer I'm zooming from, but I can't unmute it from the from the console here. So there's been Curtis has thrown in a few explanations about things, basically the get put and extended basic, and what else is. But no, there's nobody asked any questions that I've seen so far. So
Okay.
So I see Paul's screen. Okay.
All right, cool. So you guys should see what kind of looks like maybe a robot head with the right eye open and a color palette up on the left, right? Is that what everybody sees? Okay, so I had a few different methods of how I've done this throughout the years. But I'm going to kind of go through my current setup. I use GIMP graphics editor almost exclusively for drawing the graphics that I'm going to put into my games. Occasionally I'll use a Piskel app because it has the ability to animate while I draw live. But in any case, typically even those will end up on GIMP for some fine details or whatever. So if I'm going to go and hand code a sprite, first I have to have my image. And then what I will do is I will set up a grid, and I want my grid to be 2 pixels because we're working in 4 bits per pixel mode. So 1 byte is 2 pixels. And then so my horizontal is 2 and my vertical is going to be 1. And then I have to show that grid. So you can see that right now, right? Can everybody see that grid, or is it kind of a little bit hard to see? Maybe if I'll zoom in a little bit. So this is going to basically represent my byte array that I keep using the wrong tools. All the more reason to use somebody else's tools, because mine aren't working the way I want them to. Windows toolbox. My toolbox was gone. I couldn't find it. There we go. So I'm going to show you right now. I'm going to highlight the area that basically was going to be your array that Paul was talking about earlier. So this is a representation of my byte array. So what I'm going to do is I'm going to use that and my little color chart over here and notepad.
Did you have a question? Come in,
just Curtis pointed out the grid lines are kind of hard to view. Is that controllable at
all? Probably not, but what I can do, I'll do this just because it's Curtis. I will do man, it's hard to see with that stuff in my way. I will do a little expansion of that to 4 pixels.
Blowing it up on YouTube, it's not too bad.
Yeah. In any case, I'm kind of just outlining bytes from here over to the right. So it'd be 8 bytes wide by 16 bytes down. So then I'm going to get my handy dandy notepad out here. And I'm going to try to fit this all on one screen. I'm used to using 2 monitors. Using a sprite compiler software, I would only really need 1. Just going to point that out. So I'm going to use U as my reference. So somewhere in some surrounding code, the U register is going to be loaded with some sort of screen address that I'm going to blit to, okay, or that I'm going to draw this sprite to. So if we want to start the timer, I've done the setup and everything else. I'm going to hand code this live while you talk about some other stuff, and we're going to set a timer, and then I will let you know when I'm done, and we'll continue the discussion from there. Does that
All
work?
right.
I can
Sounds
go
good.
through a few lines of code too first if you want me to.
We've got the timer ready to go, so just let me know when you want us to start here.
Yeah, I'm actually going to do a few lines of code and kind of talk through it as the timer starts, and then I'll hand it over to you. Does that sound good?
Sounds good.
All right,
Here we
cool.
go.
So I'm gonna put a label on this. We're gonna call this Flame Breath 1. That's the name of the frame that I'm drawing. Okay, so I'm gonna do this top line right here. And I know I'm talking, slowing myself down a little bit, but I'm not, because I'm still gonna say, all right, I'm doing this line, and this is byte 0, 1, 2, and 3. So I have these grays. All the rest of that is not gonna be in there. So I just want to draw those grays, and I have 1, 2, 3, 4 pixels, so 2 bytes. And gray is color 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that is C in hexadecimal. So I'm going to go over here and I'm going to load D with CC. So 2 C's here, 2 C's here. And now I'm going to do store D at 0, 1, 2, 3, comma U for my first line. Now that one's done, and we're going to load effective address U and go down. And I'm using a 256 byte wide screen. So if I added 256, that would bring me here. And I think I'm going to stack blast this next one. So I want to go 256, 7, 8, 9. So 259 U, and now I've moved my pointer to here. And we're going to load X with, we got gray lines all across there. And I know that value now, but I may have to learn it again if I change anything. So, and then we're going to push on to U, X, and D, which is going to draw that line and then put us back over here for our pointer. So now we're going to do another load effective address. 256 should bring me here. I think I'm going to do this one a little bit differently than some people might think. So I'm going to start over on this side, and I'm going to mask this pixel, stack blast these 2 lines, and then also mask this one. But I'm going to stack blast these 2 bytes, those 2 bytes, and then that last one. And that's how this line is going to go. So I'm going to 256, 257, 258, 259, 260 is where I want to put my pointer. We're going to load the value from the background. We're going to AND it to mask off the right side. And we're going to OR it with the value that we want on the left side. And we're going to store that back at U. Now here comes the fun part. So when I stack blast this line, I want to do Y and then X and then A. So I need to load A first to mask it. So -1, -2, -3, -4. So load A -4, comma U, and then load my Y. And X is already loaded, so I don't need to do that again. And then we'll push Y, X, and A. Now at this point, since I've done some funky stuff, I would probably take this here, and I'm going to put it into my Sprite little tester program that I wrote here. Oh, by the way, I have to have all this code right here also coded before I can even test anything. So I'm going to pop that in there, save it, and give it a try. Let's see if we got this right so far.
So I see at least one error so far.
Yep. I think the fact is that I don't have my pause the timer. This is not counting against me. Or is it? It should actually, because this is the woes of hand compiling. So keep that timer going actually. We're already at 4 minutes. Wow. I think it's because my config file is not set up, Paul, to
Gotcha.
run this one. So I'm just gonna
Okay.
skip that. But yeah, that would be, the first initial steps of doing that, getting everything set up and then starting to hand code. And if you're like me, I like to test as I go along because it's much easier to fix as I go along than it is to fix it after I've done a whole huge segment. So with that, I'm gonna hand that over to you to take over.
Okay, thanks. So you got to stop sharing so I can. Are you gonna continue there, Paul, or you want me to
Yep.
stop the timer? All right,
I'm still going.
sounds good. All right, I'm gonna come over here and I'm gonna share my screen. And
I am
I'm
gonna
gonna
do
bring
some
up,
copy and pasting though. I'm gonna let you know that.
I'm gonna bring up my tool here, and I'm gonna select Stack Blast here. I'm gonna hit compile image, and we're done over here. So I was just curious, Paul, what's taking you so long?
Oh man, the timer's orange. It's not even green anymore. I don't know what's taking me so long, man. Uh-oh. I
gotta
see some errors. Yes. I'm almost done. I'm not though.
So wait till I tell him that wait till I tell him he's got 15 more to go after that.
I have 15 more sprites to do after this one.
You just keep going. So while he's working on that, what I'm going to do is I'm going to get started on the introduction to the Sprite compiler. And I provided Mark with the link to GitHub page where you can go ahead and grab the latest build of the Sprite compiler. And what I'm going to do is I'm going to start the tool as if you're starting it for the first time yourself. And what I'm hoping this does is, one, serves as a purpose to, show what the Sprite compiler can do, but more importantly, if there's folks out there in the community that are going to try it, how to get started with it. There is literally zero documentation for it. I'm not very good, keeping up with documentation. I do welcome anybody that wants to, possibly help out in that area. But I'm hoping this video kind of serves as a tutorial for folks to get started with the tool and see how easy it is to get, graphics on the CoCo. So it's a zip file. You go ahead and unpack it to just a folder. There's no install required, again, because it's now for release. Hopefully you don't get any warnings, any false negatives that it's a virus. Trust me, there is no virus in here, and I hope people don't run into any issues. It's not signed, but I'm hoping everybody does okay with it. So once you have it unpacked, there's some folders that go along with it, and some ancillary files. There's a change log that basically shows where the tool has come from over the last few years, and all the improvements that have been made, bug fixes and that sort of thing. I do a pretty good job of keeping that up to date. So as you guys are reporting things into me, I'll definitely update that and address any bugs as we find them. So we go ahead and start the application. The first thing you see is just a disclaimer splash screen, indicating it's your first time running it. It does indicate that you will need a couple additional tools to really take full advantage of the utility. One is William Assel's LW tools, in particular LWASM. It does use that for the compile or the assembly portion of the code. So once it compiles a sprite, it'll take that assembly code and then create a binary for you to be able to either use in your particular application, or if you want to take the source code out of the utility, you can do that as well. But the LW tools, LWASM, generates the binaries for you to be able to test. And then the other piece is for you to test, you need an emulation platform. Right now, the application currently supports both XROR and VCC. MAME will be coming at some point. I just haven't written the parser for that. But it works really well with both XROR and VCC. And I typically like to see, what they look like in the different platforms. So you only have to click through this once, but once you open up the utility, kind of looks like this. A lot of things are grayed out because you can't really do anything from the start. You can drag and drop an image into the utility. There's 3 different ways you can get graphics into the utility. You can do file open if you want to. You can drag and drop directly into the utility, or you can copy paste if you want to. And we'll step through all those. Yes.
Curtis asked, can this be run under Wine like on Linux or Mac?
I haven't tried it. At one point I was playing around with it with I can't think of the name of it. The on Ubuntu I had it running under not Wine. Somebody help me out if you can think of it. It'll come to me. Mono, yes, thank you. So at one point I was playing around with it in Mono. Unfortunately, the way that .NET works, it's developed in .NET. A lot of the controls, they don't transfer well into Wine, or not everything transfers well into Wine or to Mono. So some things might be broken. If somebody wants to try it in those environments and give me some feedback, let me know, and I'll see what I can do to possibly make modifications or improve it so it'll run on those platforms. But as of right now, it is just a Windows-based application. I do Windows primarily for development work because with .NET, it's just super easy. I like to do quick and dirty, and this started out quick and dirty, and then I just kind of try to polish the UI to make it more user-friendly for folks as I went along. But I really try to focus on the content, and don't really like to spend a whole lot of time writing GUI and controls and stuff like that. So .NET has always been the preferred platform for me, especially for anything Windows, or not Windows, a window-based UI environment. So anyways, getting back to the utility. So the first thing that you're going to want to do after you start it up, you can drag an image in here if you want to, but you're not going to be able to do much with it after you bring it into the utility. So what we're going to do is we want to make sure that we have LW tools installed somewhere, and at least one of the emulators, either VCC or XROR. So we can come into tools and settings, and then what we can do, there's a lot in here. Some of it is for dev purposes, some of it is more functionality. And again, we'll step through a lot of these. I don't know if we'll get through everything tonight. There's a lot to the tool. If we come into emulators, what we can do is select VCC and XROR. I have an option built into the utility that kind of looks for my preferred paths by default. If it doesn't find them, then it'll just leave it at the application root. And you can just hit the browse button to be able to select your utility. I'm not going to select it because it's already there. So XROR and VCC are there. If I go to code assembly, LWASM, again, I have it, just coded for my default. Again, it'll just go to application default if not. One thing that's nice, I know some people prefer uppercase assembly code formatting of mnemonics and your opcodes and whatnot. I've always kind of preferred the lowercase, so I have that on by default. But if you want to uppercase, you can go ahead and select that. Another thing that you can do is you can pair this with an external editor, and I find that extremely handy as I'm writing code and being able to bring that those code source files directly into whatever project I'm working on. So if I go to utilities, it does show that it's the application default folder. So I'm just going to show an example of browsing to a folder to be able to grab that utility. So I've got Notepad++. There's mine there. Just select this. And we got the camera in the way, so I'll hit OK. And then we'll go ahead and close. And then one other thing that I like, the application is pretty white. I like more of a dark theme. I don't have themes on this right now, but I can at least change the background of the bitmap window. So from there, we're pretty much all good to go. So once you have those set up, what you can do is you can go ahead and test functionality. I'm going to go ahead and I'm going to open up my graphics window here. I've got a couple of demos that we were going to play around with here. So my Galaga bitmap that I showed initially where we had the blitter going, I'm going to bring that in while Paul's working on.
Done.
All right, we'll hit the. So just 1 second shy of 15 minutes, Paulie. Not bad. All right. Well, do we want to get back to that, or should I continue with this right now? Or
Well, I don't know if I'm done.
okay. Do you want to take your code and test it and see what you got?
Well, let me share my results. So
Okay.
I didn't test anything while I was coding because I had to go back and set up my configuration for my dev environment. So my Notepad++, so where I do my coding and then launch my test. So my results are not ideal. Let's just put it that way.
So do you want me to stop sharing so you can show what you've got?
I do. As embarrassing as it is, I think it's
Okay.
gonna help prove the point. So let me share. I just got everything set up. Okay. But I think, we can, I think just shy of 15 minutes is perfect. Okay, so here we go. I got my Sprite code copied and pasted into this. We're going to test this out on the CoCo and see what we got. So up here in the left is supposed to look like that, but it doesn't. So there's part of my problem. I noticed about 3/4 of the way through that I started off with the wrong values for the colors of the pixels.
Yeah,
which
you
I
had
didn't go back
CC
and
instead of DD.
DD, yep, which I didn't go back and change.
Yep.
And now obviously some of my LEAUs didn't work out the way that I had planned. So I would have had to go back and edit these lines too. So I think 15 minutes is probably less time than it would have actually been. I'm guessing somewhere between 17 to 20 minutes would have probably been that for just one.
So getting through the initial one, obviously there's a little, you got to get everything set up and, you've got to get your flow, your groove on and start getting in a rhythm. After you get the first one done, do you typically pick up the pace with the other ones?
Well, yes, because if you'll notice the top 1, 2, 3, 4, 5 of these sprites is all the same. So I would take that code and just copy and paste it over. And then getting down to the bottom 4 rows here as well would be this. Well, I think it's bottom 5 actually would be the same. So we'd just paste that back down in there. So we'd have to just worry about 2 lines at that point that would need to be modified. But then once you start to get into more of the animation sequences and things get a little bit more complex, you're not able to do as many copy and pastes anymore.
Gotcha.
I also, I can't see any of the animation going on with any of this. I'm only able to see the frame that I was currently working on. So there you go. I was sharing that whole time, right? I didn't stop my screen
And
sharing.
you had stopped sharing at some point, but yeah, we did get the gist of what had happened and where it broke apart and how much of a time challenge it is to do these by hand.
Right. So just real quick again, like I was able to basically take these first 5 rows and just copy that code to draw this next sprite. But then as you get farther along the animation sequence and the changes start happening, you can do that less and less frequently. So
Gotcha.
and we had 15, so I had 15 more to go.
Yeah, after that, so a total of 16 for that one particular sprite.
So let's just be conservative and give me 15 minutes because I'm a rock star at doing it. That's 240 minutes. So 4 hours
to do one sprite. And what happens when you change the colors and you find an error?
And I would say that's basically, well, finding the error is going to add a little bit more time, but if I modify this sprite at all, change the colors, anything like that, I mean, I don't have to necessarily start back at ground zero unless I'm like completely changing the whole entire, the way that it looks. But changing colors, you'd still have to go and search for those colors within it. So it'd probably be another couple hours, if you
replace
changed
the color values with a label that would be unique, so you could just search and replace that label.
I suppose you could do that. But I don't know how well that would work when you're actually like loading individual, like you'd have to have these patterns labeled, right?
Mhm.
So CCC would have to have a label and then you'd throw that in there. So you'd have to write a label for every single sequence that you could possibly have of a byte order. I don't know if that would be any easier. I mean, maybe if your sprite was 64 by 64 pixels, maybe, but even then I still wonder.
So it's funny that you mentioned that, Marco, because and I've showed Paul examples of this on stuff that I've been working on. I've got some examples where I've made some tweaks to the sprite compiler that does just that, because I've got objects in some of the work that I'm doing that have different colors, and rather than having different copies of the sprite, I do specifically that. I've got a lookup table that basically defines what the color patterns look like, and all I do is reference that lookup table for each color combination that I need for those respective sprites, and I can change the compiled sprites on the fly and within my source code, and looking to bring that type of functionality into the sprite compiler. So yes, by all means, it's something, if we have the ability to do that, it can save loads and loads of time.
So this is what it should have looked like. Well, okay, that's the one with his eyes closed, but yeah.
Cool.
There you go.
And you've got him on. Go ahead. Hey, Curtis, welcome.
Hi. Paul, I was just going to mention, like you were mentioning, you'd have to create all these, like if you want to do equates, like gray equals, 2d6 or CC or whatever it is. But if you want to do like single and double ones without define all the single and double byte offsets, you could do gray times 256 plus gray as part of an FCB or something, and then you would actually get, a double CC.
That's true.
And do singles and stuff. Not that I would recommend doing that over Paul's sprite compiler.
I wouldn't even recommend that. I think coding a sprite by hand. I just think that you have a lot of overhead, and that's a lot of things to type out too when you're actually doing it. So
yeah, I mean, I might recommend doing it once, just so you can kind of figure out what it means to have a compiled sprite, so you can truly understand what it is. But then after that, I would immediately ditch doing it by hand.
Oh yeah, no, I'm talking about doing the gray times 256 or whatever, you know. I guess I can see its use in, you know, but like when you're repeating that over and over again just to sit there and type that or even copy and paste it, I don't know.
Yeah,
That's just my opinion, but
it'd still be slow.
yeah.
Now, Paul Fiscarelli, I wanted to mention there was one comment I made. I don't know if Mark caught it earlier here, but other people have tried to, figure out ways to get around having to create compiled sprites because back, in the old days they've done by hand. And one thing the Sierra games did is that they create a 320 wide 16 color screen, but they treat pixels as full bytes. So they're like the double fat ones. It's kind of like doing the simulated 160 mode. But that way you don't have to worry about masking nibbles or anything. So basically it's just straight load stores or pushes and stuff. And that's what they did is speed it up, but you're taking twice as much memory for half the resolution.
Exactly. And I'm actually working on something right now, Curtis, that takes specific advantage of that. That type of it's too soon to talk about it. I'll share it at some point, but I don't want to make any promises on delivering and not being able to deliver it. So, but yes, I do have something in the works that takes advantage of that double byte mode or double pixel mode, take up full bytes. So there's no masking. And actually there's functionality in the utility now that kind of gives you a sense as to how much masking is actually required and, where, you're going to lose efficiency. So I'll get into that. I'll show that as we get a little bit further into the demo here.
I mean, even as it stands, if you were to draw your pictures in a way that would just be no masking required, this would still get you the same result. You could
it'd still be faster. You just wouldn't have to do the ors and ands and stuff like that. It'd just be straight store.
So,
but
anyway, so Paul, I saw you have the stopwatch queued up. Are you going to now time how long it takes for this to compile all 16 of them?
Yeah, I was wondering if somebody would be able to hit the stopwatch so I can go ahead and compile this. Oh wait, I've already got a stopwatch built into it and it's done. I didn't turn on, so I should probably turn on the compile sprites. And what I can do is I can turn on verbose mode so I can see details such like that. So I'll go ahead and compile this again. And the actual compile time was what is that? 500ths of a second. So I think that kind of beats the 15 minutes by a bit.
You don't
so
have
one
to be a
thing,
jerk about it.
Actually, Paul, one thing I'm curious, while you're taking a look at yours, can you just pull up, the number of cycles and the number of bytes that's taking up? I'm just so we can do a cross comparison of, how efficient the sprite compiler is becoming, how optimized it's getting.
The answer to that question is no.
Oh, you can't. Okay.
I didn't do an assessment of bytes or cycles that I did this. I don't have it. I don't have it documented anyway.
Fair enough. So the other thing that the sprite compiler is showing you right now in the output verbose mode, and again, this is, you can turn this all off if you don't want it there, but it shows you how many cycles it is for each frame, as compared to what the raw cycle count is, and the raw cycle count is just based on the size of the array itself and just some overhead associated with it. But it also shows you how much overhead's associated with the byte count. So after it's done compile of the sprite, how many bytes is it taking to actually now draw that, as opposed to the 2D array buffer that was previously stored for that sprite. So that's where you can kind of see the trade-off. So something for like this, particular image, it's showing you that it's 244.6% faster than doing a typical blit method, but at the same time, it's about 70% larger. So that's where you have the trade-off. So, when it comes to compiled sprites, you got to keep that in mind. They have a tendency to be on the larger side, but if you're looking for your pure speed, it's definitely the way to go. Luckily, with the CoCo 3, nowadays we've got easy access to 512 and 2 meg upgrades, especially on the virtual platforms, on the emulators. So we have the ability to take advantage of that.
It's virtually endless space.
It certainly is. So, I mean, granted, you have to do some thought and consideration as you're writing the code as to how you're going to use the MMU and page in those memory blocks. But if you get good with it, it's well worth the trade-off.
It's also nice to notice in your verbose statement there, you have the CoCo render time. So how many seconds in the CoCo is it actually taking to render?
Yeah, so
that?
that's based on the cycle count. And that's kind of nonsensical to some degree, but I just kind of threw that in there just as a quick reference to get a sense as to how quickly it's rendering on the CoCo. So one way that you can think of it is typically on a CoCo, a single VSync, if you're running at high speed poke, you've got about 29,000 cycles and change to play with each VSync cycle. So if you're rendering this, you've only got 426 cycles for this particular sprite out of 29,000 plus. That's a lot of sprites you can throw around on the screen. Granted, you've got a lot of overhead of other things going on, as far as management of game logic and other sprites and graphics and music and all that other stuff. But compiled sprites can play a big part in making extremely fast CoCo games. So what I'm going to do is I'm going to bring back the Galaga bitmap again real quick. And as you notice, I just dragged that into it's just basically taking from wherever the window is and just dragging it in there. As opposed that's my preferred method. You can, if you wanted to, you can do copy. Where's copy? It's down here. Stupid Windows 11. And then you can just paste that in there. So it's your preferred method. So we'll just drag and drop that in there. So one other thing I was going to mention about the utility that I just want to clear up, because people have asked, this is not a graphics editing tool. It's not going to allow you to create sprites. It's not going to allow you to easily manipulate sprites. There's programs out there that do a much better job of it. And as Paul mentioned, he primarily uses GIMP. I use GIMP consistently. There are other sprite engines out there that you can draw sprites. This one, you can actually directly import and export Piskel files. I know that Piskel is somewhat deprecated at this point, but it's still useful if you have a copy of it. So if you do create some sprites in Piskel, you have the ability to bring them directly into the application. So looking back at the utilities, so for folks just to get a sense as to all the controls that we've got here. So the primary window here is, showing us the image itself. And what we can do is we can mouse wheel to zoom in, if we wanted to. We've got a little dial here that if we want to, zoom in and out of it. Right now I've got columns turned on and I've got rows turned on, and those are just nice to have for reference. So we can turn those off and get rid of those. If you want to see individual pixels, what you can do is you can turn on a pixel grid view, and that shows you pixel by pixel what the sprite looks like. In addition to that, what's a nice view is going by byte boundary, and that's showing you where your actual bytes are and where they break, where the bytes break. And I can turn the rows back on and columns. So with the columns back on, you can see that we've got 0 through 7, so 8 bytes wide. If I turn that off, it'll go back to a pixel view, and we've got 0 through 15, so 16 pixels wide. So we can turn that off. So once we've got it imported in, we've got our palette down here, and it's just basically showing us whatever we pulled out of GIMP or whatever we pulled out of our tool, it's bringing that palette over and preserving that palette from the bitmap image itself. One thing I did want to note is the application in its current form, you can use 2 specific formats for drag and drop or file and open, and that's bitmap and PNG. I at one point thought about including JPEG, but JPEGs have a tendency to be so compressed and so blocky, there's really no point in doing it. I mean, it's easy enough to do the parser and easy enough to be able to bring the image in, but once you get it in there, it's not going to bring pleasant results where you're actually going to be able to use it for anything. So the two preferred formats again are PNG, which is a lossless image, as well as bitmap. So what it'll do is it'll bring the bitmap over. If the bitmap is less than 16 colors, as this one is, it's showing us that it's only got the 4 colors here. If it's more than 16 colors, what it'll do is it'll do an approximation of the colors and try to color correct based on the closest neighbor. So it basically does a 3D nearest value for RGB, and we'll try to approximate the color, and it'll reduce colors. I've added the ability for things like dithering, and which we'll get at some point, and that's really useful on doing a image, bringing images into the CoCo. But for the purpose of sprites, again, PNG and bitmap. So we can see we've got it currently set to CoCo RGB palette. You can select it to CoCo CMP, but as many in the community know, there is no one-to-one correlation for CMP to RGB. So if I select this, it'll try to do closest neighbor, again, closest approximation, and it does an okay job. And you can see the palette changed on us. If I go back RGB, we're not going to have the original RGB palette because, again, it's trying to do closest, and it's not going to be quite the same. So what you can do if you want to reset the palette is you can just come down here and you can reset the palette. Another thing that you can do with the palette is we've currently got it set where we've got values 0 through F, and those are representative of each of the 16 palette slots on the color computer. What I can do, though, is if I want to see what the actual color value is, I can come down here and select from index value and go to color value. And we can see here, palette 0, we've got color 00, palette 1, we've got slot 1, we've got 63, 36. You can also mouse over and it'll give you a RGB representation of that palette value as well as the hex value. So if you want to see what the color values are, which is nice to have as a reference, and a lot of times what you'll see is there might be duplicates in there, or they're really close, and you're like, huh, is that a duplicate? Turning the color values on gives a nice way to take a look at that. So we'll go back to index values. So as I mentioned before, what you can do again, yep.
Yeah, we're right at about an hour now. Did you want to take a break, or you just want to continue on?
It's up to you guys. I'm ready to keep going if you guys are.
Okay. Like I said, we're hoping to do this in like 2 hours or so, or a little bit less, or maybe a little bit more, but we'll see. Okay. Well,
yeah, we'll see how far we get into it here, but I can keep going. I'm good to go.
All right.
So, so taking a look at the palette again, what we want to do is once we bring the graphic image in, what we need to do or should do is set the transparency value, and it'll actually automatically select a transparency value based on whatever value. It does a pixel count, a color count of the bitmap image, and it'll basically say, okay, this value has the most occurrence, which happens to be black in this case. So palette slot 0. So it can it'll automatically select that. However, what we can do is we can go ahead and select that as transparent, and you can see that it changes the value here, and you can manually select whatever value you want if you want to scroll wheel through all of them. Getting back to looking at the color count, if we go ahead and we right click on the palette again, what we can do is we can show a palette distribution. And what that does is it shows us our color count by pixel. So it shows us, we've got 144 pixels that are black, 84 that are white, 24 that are red, and 4 that are blue. May come in handy. I do reference it from time to time. And again, mousing over each of these values shows you what those respective palette slots are, as well as the color value. So we can go ahead and close that. Another thing that we can do with the palette, which I use quite a bit, is you can mouse over this and it'll show you the 16 color values separated by commas. You can copy that to the clipboard, which is real nice to bring into your source code if you want. The other thing too you can do is if I want to highlight a particular color, see what where that color is in a particular graphic. And this one, it's 16 by 16. So it's probably not as, not needed that much, but you can go ahead and you can just right click and you can say, all right, I want to highlight that color, and it'll highlight all the red pixels for you. Or if you want to highlight all the blue pixels, you can highlight all the blue pixels. You can turn that off. So those are some of the functions of the palette. Another thing that you can do is if you want to see what the actual transparency looks like based on the color value you have selected, you can come up to the image itself and you can say, I want to see the background transparency. And there you've got your transparency on the image itself. So it's just showing you as a reference. So it's treating that as transparent color. If we select that as transparent, it'll modify that accordingly. So you have a little bit of flexibility there. We can turn it off. Not really necessary for this specific image, but you can show the sprite mask. So we're currently selected 3, so we'll go back to 1. So it's showing us what the actual mask is of the sprite, and we get a representation of the mask data over here on the side. Why this is of importance is because it uses the actual mask to calculate the transparency. So when it's doing masking of pixels through the compile process, it takes advantage of it there. What I mentioned to Curtis earlier, where we were talking about pixels that require masking, you can come up into tools here, you go to settings, and then what you can do is you can say, I want to turn on the color mode sprite mask, and it'll show us the green pixels, and I'll turn on the byte array so it's a little bit easier to see. The green pixels are showing us where we have even byte boundaries. Reds are showing us where we've got to do masking on our least significant nibble, and red showing us where we've got to do masking on our most significant nibble. And what this is really helping you see, when you're doing masking, there's a lot of overhead associated with that, and it's going to raise your cycle count. It's going to raise your byte count. So if you can minimize the masking on a sprite, you're going to get more efficient results. And we're not going to see it too much here, but one of the things you can do to kind of get a better sense as to, where you might be able to shift the sprite to get better results. All that's doing is it's swapping the most significant and least significant nibbles. But, if you were to move a sprite by, a pixel or something, you might get some better results.
Question on that real quick.
Yeah.
Do you have a numerical analysis of that? Like what percentage?
I don't yet, but that's coming. It's on my to-do list, but yes, it'll be nice to see how much overhead is actually associated, how many additional cycle counts are required, how many additional bytes are required, just so you have the ability to go back and reanalyze your sprite and possibly rework it to get on even byte boundaries. Yeah, I've already got the background. The numbers are already there. All I got to do is just write a little algorithm to report it. So
Yeah,
not
cool.
that big of a deal. So composite overlay, we won't show that just yet. That'll, that's when we've got multiple sprite images, multiple frames. Some people like to see, white on black versus black on white. You can invert the mask if you want. That's not really a big deal. These two settings down below are dev settings, so you want to leave those checked. I turn them off when Paul and I turn them off when we're writing code. Just makes it a little bit easier where we've got our RTS on each frame.
Paul, I just want to ask a quick question. This is based on people that are familiar with the hardware sprites and the other machines you were mentioning, like Commodore 64 and Ataris and stuff. They used to have restrictions in the hardware, both of how many colors you could have in a sprite compared to the graphics mode you're running on.
Yep.
And also most of them had fixed sizes. You're only allowed certain, multiples of 8 or whatever. Do you have any of those restrictions in your compiler too, or is it pretty well freeform?
No, it's completely freeform. It's whatever you want to do. It's whatever memory is going to allow you to do.
Okay.
So one thing I did want to mention, and it's a recent addition, the compiler does support full 16 color sprites with transparency, and it does that through the sprite mask, the image mask. So you can see that that's grayed out down here. And the reason why is because we've got a 16 16 color bitmap image, but with a bitmap image, when you're doing 4 bits per pixel, you don't have anything left over to select a transparency. Bitmaps don't allow you, don't support transparency. However, if you were to take a 16 color transparent PNG file, which I'll show in a little bit, drag that in here, it'll show that sprite mask as selectable, and that'll give you your ability to do 16 colors with a full image transparency, and you don't have to select a background color, sacrifice a background color for that.
Yeah,
boy. The none is just basically exactly that. It'll compile the sprite as if it was just blitting it all the bytes to the screen, and in some cases that's helpful, because if you say, like, if you got a font or something like that, and you want to have type over on each of the individual characters, rather than to have to erase all those characters, all you have to do is write a character over the top of it, and it'll write the background with it, and it makes it extremely helpful. So having none is helpful in some circumstances. It's advantageous for smaller sprites. Larger sprites, you're probably going to want to have transparency, because it'll definitely optimize things. And just to show you a quick example, so if we've got a background color of 0 here, and I come over and I hit let me raise this up a little bit, compile image, we can see that it's 693 cycles, 368 bytes. So Paul, how many cycles did it take to blit the image, did we say?
It was 3,831 cycles.
So here we're seeing 693, and that's with the background transparency. So if I turn background transparency off, and then I do a compile image, actually it went up, and that's a rare case, because what it's doing is a full stack blast of the image to the screen.
Interesting.
Wait, hold on one second. Is that right?
That shouldn't be higher.
Hang on one second. What does that look like?
Well, that's smaller.
It
It's
is interesting,
525 cycles.
but it still looks like it's doing. That's interesting. Wonder if I just found a bug.
I'm not seeing what you're seeing in the code.
Am I still sharing?
Yeah, you are.
That's interesting. I'm gonna have to take a close look at that, see what it's doing.
So your background color should be 0, right?
Yep.
Compile, you're at 659. That's with transparencies.
Yep.
And what was the byte count?
Yeah, that's right. That looks right. So we turn stack blast back on, and it says 525.
Yeah.
I'll have to look at that. I'm not sure if that's right or not. I'll have to take a closer look.
525 is the lower cycle count, right?
Yeah. That's interesting. I'll have to, it's drawing it properly, so it looks like it's doing something right, but I'll have to take a closer look at that.
I'm not understanding what the problem is.
It just seems like it's lower. I mean, to me, that's a shocker. Typically, when you have oh, you know what? I'll have to analyze it later.
Yeah.
It
should be a lower cycle count
when you're doing no transparency.
Yeah, and you're stack blasting that whole thing.
Well, it depends on if how big the image is and how much background you actually have.
Yeah.
So
yeah, this is how much you have to, what your byte mixes are going to be and whatnot.
That's right.
Yeah.
But it could be right.
So 659 cycles with transparency for a total of how many bytes was that if you do the transparency background color again?
So we'll turn that back to black, compile image, 693 and 368 bytes.
693 and how many bytes? I'm sorry, 368.
368.
So the savings in cycle counts, 383, yeah, 693 divided by 3831. So you got 82% of it wiped out of your cycle count.
That's
82%
amazing.
gone. And then your 368 byte count is just a little bit over double. I mean, a significant increase in speed for just a little bit over double your RAM space.
Yep.
And
And for-
honestly, the RAM space that we went with was including the code to do the blitting.
That's right.
So if you take that out, yeah, well, that it's still a little bit more than double, but yeah. Seems like a pretty decent trade-off to me.
It seems like a pretty good trade-off. Yeah. And again, you know, with where you've got CoCos that are 512 2 meg these days, you know, compiled sprites are much more accessible. So yeah, so that's kind of a high level overview of some of the functionality of the palette, the background manipulation. We showed transparency. I won't get into scale and crop image just yet. Border color was just changing the border of the frame here. So it does have the ability to kind of manipulate a little bit. Just, you know, if you want to shift things around, if you want to flip things, invert them and that sort of thing. And I just added those because I found that those were kind of helpful. And where it's extremely helpful, I'll bring in another sprite here. Not these guys here. I've got it off screen. All right, I'll bring this guy in here. So a lot of people recognize this guy. So what I can do with him, and this will show the next steps of functionality of the tool. So we turn the pixel grid on there. So what we can do with a sprite sheet, which is what I just brought in here, it's three frames of the Mario character, as I can select enable frame split, and I can split up my frames, and we want to do 3 frames by 1 frame. And if I hit the split button, we can see as I'm moving the arrows here, the horizontal and V sizes of the frames, I'm going from red to green. And red means that you're not on even byte boundary and you can't do a split. But if you go green, that'll allow you to do a split. So it looks like we're good there. So if I go ahead and set split, we've got our Mario character split into 3 separate frames. And what we can do is we can look at each one of these individual frames with our little slider here. Or what I can also do is I can animate them just by hitting the play button and stepping through each frames. We do have the ability to adjust frames per second. So drop them down to 8 frames per second. If we want to go backwards, we can go ahead and, you know, animate the frames backwards. But what I can do at this point is I can, instead of compile the image, what I can do is I can compile the frames. And what I've got now are 3 compiled sprite frames here for each one of the frames of the character. And then if I go ahead and hit test and bring my window over, there's our Mario character running. Do I still have him? No, he's going forwards. So what's nice about the function, and the reason why I brought him in particular, is now I've got 3 sprite frames for Mario running forward. But what I can do is I can go back to my original image by hitting the reset image button. It'll bring me back to my uncut sprite sheet. And then what I can do is I can reverse the order of him, hit enable, and then we do a split. And now we've got Mario running to the left. And then if I hit my compile frames, it keeps coming up off window. There he's running there. So it makes it nice where, all of a sudden, with just a couple clicks of the button, I've got two separate animations to bring into my utility. So that's, kind of how the frame split works, showing the animation. What I can do is, if I want to see what he looks like running faster, I don't have to do a recompile, because all we're doing is VSyncs, counting VSyncs for the animation. So if I want to bring them up to 30 frames per second and then test them again.
That's 20, but.
Yeah, sorry. Yep. What did I say?
30.
There we go. So you can see what it's going to look like on the CoCo running at the various speeds. So over here on our output window, where we've got the compiled sprite, what I have the ability to do is change some settings of the utility for my target environment. And those variables that we can change, we can turn HVEN on and off, which basically is for 256 byte wide mode. But what you have the ability to do is target a frame size of, whatever you like, for a width of 32 bytes all the way up to 160 bytes. So this is nice for when you've got sprites that you want to bring in from the edge of the screen, where you've got the cropping handled automatically for you, or if you have scrolling, if you're scrolling HVAN left and right for your scrollers and whatnot, you have the ability to do that. You can change the height of the window if you want 192, 200, 224 scan lines. And then you can also adjust the lines per row. And what's really neat is Paul uses this for a lot of his games. So he'll go to 2 lines per row, 224 scan lines, and then 64 byte wide display. So if we can hit compile frames, what you basically have at that point is your double size Mario, because that's your 128 by what is that, the 112 resolution, Paul?
Yeah, 112.
128 by 112, yeah.
So it'd be whatever your horizontal height is divided by your lines per row.
So it supports all different sorts of settings, and it makes it really handy to be able to get those graphics in. So what I can do with this output is this is copy and paste. So if I want to bring this directly into my source code, I can just copy and paste this content. Because I selected Notepad++ as my default editor, what I can do is I can say, all right, I want to edit this directly. Do I have Notepad++ set? Might need to restart the application. It says that I do. I wonder if it only checks it on the start. That might be a little bit of a bug. Let me restart it and see what happens. Go in, enable the split. There we go. So we have the ability to do just the sprite code itself, or if you want, you can do the full sprite code. And the difference between the two is, I'll bring up the other one just to show you the difference. So if we do edit sprite code, so edit sprite code is just showing us the compiled code for the individual sprite frames. So the 3 frames are right there, and that's all it is. There's a little summary page, comment section that shows you the total byte count and the total cycle count for the entire 3 frames. So if you want to get a sense as to how much each sprite is in aggregate, you have the ability to see it there. So what I opened prior to this was the actual full sprite code. And where this is helpful, it's showing you the entire executable assembly code where you can assemble this right from scratch, and you have a running image. And what's nice about this is for people that may be just getting started with graphics or the utility, it shows exactly how everything's set up. So it shows, how to set up, where your video start and video end is, setting up, turning off your interrupts, moving your stack around. And I, move that around depending on what I'm doing for, the backup and restore of sprites, showing you, setting high speed mode, shows you how to set up your gimme registers, your V mode and your VRes for your different graphic settings. It goes into a little bit of detail there. Most of this stuff is commented. Some of it, is not commented yet. Setting up your MMU banks where we've got 5 times AK blocks at a memory address 6000 since we're starting at FFA3. Setting up the palette where we're, taking all the palette information that's exported out of the utility into the code itself, where we're actually doing a clear screen of the graphic screen, and then where we actually plot the sprite. So basically all we're doing is I have some maths in the application that's just finding, based on the sprite size, based on the resolution that you set, the center of the screen, and that's why it's such a weird value, that 99cc. And that's where it's actually storing the graphics. There's our clear screen where we're waiting for VSyncs, and again, it's very crude. So 6 VSync cycles basically is a 1/10 of a second. So that's where that's being set, and why, how you adjust the frame rate. And then there's our sprite graphics. So it's a nice little output that basically shows you how to draw the graphics on the CoCo and what's actually happening step by step. So for folks that are just getting started, hopefully that's of help. The other thing that I can do is, if I wanted to, I could take the raw FCB data, and this is what I took the data for when I was blitting earlier. We can turn the row numbers off, and we can copy that directly out. If you want to plot by column versus by row, you have the ability to transpose the values, so you can do it that way. You can turn this off entirely if you want, because that's turned on by default when you have the animation going, and you can actually see the byte values change as he's running, which is kind of neat.
A real life example of the transpose. If you guys are familiar with my Redbeard Spotlight logo, I use this utility to transpose that data into columns so that I could plot it.
Yep, that's a really good example of it. Another neat feature of this byte data output, you can actually use this for tile data. And the way that works, I'll drag this image in here. You guys might recognize this. It's the tile set from the first level of Mario. And I used this for when I created my Mario demo. I'm not sure if everybody's seen that. It's been a couple years ago now. And it was just, again, me playing with the sprite compiler, taking some of the assets and being able to use them directly in assembly code. So if I hit enable, and then what we can do is we can carve this up into individual tiles. So it's 16 tiles wide by 2 high. And then what I can do is I can hit split, and if we want to, we can cycle through those at 10 frames per second. But what I can do is I can come over here, and if I right click here, I can say, all right, show me all the frames. And then boom, we've got our tile data right there, and they're all referenced by an individual symbol label. And you can just copy all this and bring that into your code for being able to draw a tile set and create a level, or whatever for your game or your application or whatever. So it's a neat little secondary feature. Another place where this is handy, and this was, I basically put this in there specifically at Simon's request, is things like a game font, or some of his Gimme Games demo stuff. I know that he was using some character fonts and stuff like that, so it was really helpful for him to be able to slice up font pages and be able to have the FDB statements, the tile data directly to use. Okay, so that covers the byte data area. So looking at the sprite compile, again, just real quick, we'll get back to that. I'll bring let's bring something a little bit different in this time. So a
About
little
27 minutes left, just to let you know.
Thanks, buddy. So we can go ahead and split him up. That's the Goomba character. So over here, we have a couple different methods of compiling the sprite. And depending on what you're doing, what your code's doing, and different people have different tastes for how they write their code. You can select different index types. So I typically will either index with the U register, and the other way that you can do it is with ABX. ABX is really nice because it's faster than doing a typical LEAU offset indexed method of going scan line by scan line. And we can see the difference between the two. So if I go ahead and compile this image, so using ABX method, we can see what it's doing is it loads B with 160, which is our byte width, and then it adds B to X. So using X as the index value. If you're doing 256 byte width, what's neat, this is even faster, or I think it's an even trade-off at this point. If you do 256 byte and do a compile on that, it'll do ABX twice. So it's smart enough to know, let's load 128, do ABX twice, and there's still a cost savings with that, doing it that way instead of an LEAX offset. So we'll go ahead and turn that back off. And 634 cycles, 349 bytes using ABX. If we go to LEAU and do a compile there, slight increase. Depending on what registers you want to use, how you want to do it, you have some flexibility there. I typically am always using ABX. But we can also do stack blast, and depending again on how much contiguous spaces in the sprite itself, this one seems to be quite a bit. So stack blast will probably pay off pretty well. So if I hit compile image there, we'll go down to 615 and 306. So definitely a good savings there. But not everybody has the ability to use the stack for their sprites. They might be using the stack for other things. So if you don't want to use the stack, you don't have to, but it gives you a few different options to be able to compile the sprites. Right now, it's only doing it by rows. I started playing around with the ability to do it by columns. And what I mean by that is it'll do an entire row and then move down to the next row, and then it'll do that row and then move down to the next row. So that's doing a compile method by rows. However, if you're not using something like HFEN and you've got clipping happening on the adjacent edges of the screen, and you only want to plot either a single column of bytes or two columns of bytes, the functionality is coming where you have the ability to compile by columns, where it'll move from column to column to column. So you can carve up a sprite that way, and just have a little bit more flexibility. Let's see what else we have here. Go back into settings. We talked about.
I just want to make a quick note. So
yeah,
what's nice about what Paul just went through, I want to mention a little bit about indexing. For those who kind of don't know assembly or whatever, basically what that is you're going to use one of the registers. This program allows you to use the X or the U register to point to the screen address that you are going to plot your sprite to. So that's what that means when you do that. But what's nice is, let's say, for any given sprite, you can use a varying technique. So you can choose between the ABX indexing, the LEAU, or stack blasting. What this utility allows you to do, especially when you have the verbose header selected, is you can compare which sprite plot is going to be, if you're going for speed, this one's the fastest, this is the one that I want. And you can mix that between your sprites. They don't all have to be done in the exact same way. So that's just a note from, as a user, something that I think is cool.
Yeah, no, thanks for annotating that. And you're exactly right, Paul. I mean, it does it is pretty neat how it gives you that flexibility. Let's see here. Talked about the emulators. MAME is coming at some point. You can select your default emulator. Oh, real quick, just to show you how you can choose between your emulators. So if I've got we can compile frames on the Goomba here, and then if I hit test, what'll happen is it'll automatically come up to VCC because I have that set as my default. But if I want to see what it looks like in XROAR, what I can do is I can right click here and I can go ahead and select XROAR and give XROAR a little love. And there he is running in XROAR. So VCC is turned on by default. You can select XROAR as your default emulator, at which point if you just hit the test button, it'll go directly in XROAR and you would have to manually select VCC. Logging, I've got that turned on by default. And there's a debug log that's generated, and it's basically just creating a trace log of everything that's happening in the utility as people are going through and using it. If you do run into issues with it, with the application, I'll probably ask you for the debug log so I can take a look and step through and see where issues may have occurred or where certain values may have triggered something, use case in the application that I didn't account for.
Yeah, we've done that a few times, haven't we?
We certainly have.
Hey, Paul.
It's been, yeah.
Sorry, can I interrupt you real quick? And Mark, has there been any questions that popped up or anything like that? We have like 20 minutes left.
I have the one I asked in the Zoom chat. I can repeat on the air if you want.
I didn't see it, but go ahead, Curtis.
Well, when you guys were going through the different versions of doing the indexing, where you can use U for stack blasting and X for fast ABXs and stuff like that, I was wondering, do you have any plans for eventually supporting the 609? Because it's got that nice W register that you can use both as data and as an index register. And if you're using, say, HVEN, and you want to jump 256 bytes at a time, you can actually just do an INC-E or an ADD2 if you have to jump 2 lines or something like that. It's even a little bit faster yet. And I don't know if that's something you're planning on or if that's like far in the future or what.
So I would say far in the future, Curtis. I did leave some places of the code where there is flexibility to select additional registers for compiling code. Other areas are more hard coded when I'm doing, sprite analysis and stuff like that, as far as how wide of a path, a data path I'm looking at. So it would be great to take advantage of 6309 capability, but that's probably a bit in the future if we're going to be able to support that.
Okay. Yeah, no, just wondering. I'm not trying to add feature creep or anything here.
Yeah, no, I think it would. I think it would be awesome for sure.
I just know though, since we've gotten a couple 6 or 9 required games like Gunstar, and now Glenn Hewlett's working on one now too. He's porting an Amiga game for 2 meg RAM, by the way, required.
That's awesome.
That he's actually, I think he's planning on it being 6 or 9 only, and he's probably using handmade compiled sprites on it, I'm guessing.
I would imagine, yeah, for sure. But yeah, I would definitely like to support that. One of the things that I need to do personally is get some time with 6309 and do some coding. I've done very little with it, so me becoming more familiar and more like I said, familiar with it, then I think I'd be more favorable to support it and be able to.
Yeah, I'll warn you, once you get started, you're going to get spoiled.
I'm
don't
sure.
wuss out. Don't wuss out. Keep going on to 6.
I'm not saying don't do 609. Do 609 first, get it done. I mean, then if you feel up to it or have time for it or whatever, then I wouldn't mind seeing at least some 609 support in the future.
Yeah,
I need more registers.
And
yeah,
TFM,
exactly.
sorry.
And 32-bit wide data paths.
Yeah, I know. I'm just kidding.
Yeah, it would be super cool. The utility section, again, showing you where you can use an external editor. So dzip utility, I'm using dzip, which is Kieran Anscombe's deflate utility compression utility that he came up with because it's so lightweight. I know that there's a couple other ones out there. Doug Matston's has one, and there's another one Simon was playing with.
Yeah, because I remember Karen's the decompressor is like 256 bytes or less or something like that. It's like really small.
It is ridiculously small, and it's for what it is. I mean, it's relatively fast. What I'm using that for is the ability to do compression of full screen images. And if we have a few extra minutes here, I'll show that because I know that's what got Ron, using the utility. He likes it for being able to do the graphics conversions. But dzip works really good. So initially the application was doing a shell script out to the console using his dzip file, but he includes with the distribution the C source code, and I've since transcoded that to .NET, so it's handled directly in the application now. So I just need to do the conversion of how I'm parsing the image file to get that completely out of there, but it's still going to be using his dzip compression method. And I do include a note to him, thanking him for it, as well as his full source code and everything with the distribution. So that's why that's there, and it's grayed out, so you're not able to change it. Code assembly again, LWASM. If we wanted to, like I said, we can do full uppercase. So we'll hit close, and I'll do another compile frames on that. And then, everything's in uppercase, and I've just never been a fan of. I mean, I used it obviously with EdTasm, but way back in the day. But these
I was just going to mention Nick Morendes is going to like that because he still uses EdTasm to this day. So
yeah, so that's there. If people like that view, I have a tendency to like keeping it at lowercase. It's less shouting at me, I guess. Sprite and graphics. This tab's got a lot of different features on it, and again, you can import Piskel. We won't get into that tonight. I can definitely show that at some other point. But import and export Piskel. Actually, one thing that I'll do real quick, just because it's there. We already have a sprite sheet, but if you had something where you're bringing it in from like Piskel or whatever, Piskel is a contiguous concatenated set of frames. But if you wanted to, export that as a sprite sheet, you have the ability to play around with that a little bit. Why is it? Oh, because I didn't split it. It's only one graphic, so obviously it's not going to be able to split one single graphic. Here we go. So we do export sprite sheet. So you have the ability to, just play around with different sizes and different layouts for the sprite sheet if you wanted to do that. I'll let you do certain sizes and whatnot. So anyways, it has that functionality built into it. So go back to settings. So these are just annotations on the so it's showing you in the output, each row is there's a comment. You can do individual cycle and byte counts. Those can get a tendency to get ugly after a while. Here we've got the image conversion settings, and I'll show that real quick. We've got about 15 minutes left, and I'm sure if Ron's watching, that's what he's been chomping at the bit for. One other thing I did want to show real quick is how you can export different data formats depending on what you're doing in the utility. So one thing you can do is if you want to just export, the image itself as just a raw binary, which is just basically a concatenation of all these byte values here as a binary, you can do that. You can do a binary executed frame animation. And the reasons why it's not letting me do that is because I haven't compiled frames. Once I compile frames, if I come here again and show export, why is that? I'm not sure why that's grayed out. I have to do a test. There he is animating. That's what the full animation looks like. That was Paulie was working on.
I think that actually was a picture of Paulie trying to figure out all the hand assembly version of it.
Yeah, so I actually had to do a test to create the binary source code. So if I do an export of this, what it's actually going to do is create an executable binary that I could drag onto a disk image that shows exactly that sprite frame animating on the screen in the middle of the screen as it was. I can also do the same thing if I just want a single image, which would be this image that's in frame right now. If I want to export that single image as a bitmap, preserving the entire palette, I can do that. I can export it as a dzip compressed blob that you can use, to import if you do an include, bin file or something like that within your code. You have the ability to do that. But I also have the ability to export that animation I just created as a sprite, as a Piskel sprite. So if you want to import that directly into Piskel, going back and forth between Piskel and the sprite compiler, you have the ability to do that. So with the last 10 minutes here, I'll really quick go over the latest functionality of the utility, which is kind of secondary. And the reason why I came up with this is because as I have been working on projects and playing around with different things, it's really neat to see these sprite animations, but a lot of times I've wanted to see what actual graphics, full page graphics, splash screens, bitmap images might look like on the CoCo. So I came up with this latest functionality, and just to show a quick example of that, we'll bring over something like this. This is just a Adobe stock photo. And this is, if you've ever seen this site, all it is just pages and pages of different graphics images. So what I can do is I can just come over here, I can right click and I can do copy image, come over to the sprite compiler, and then I just hit paste. And I have the byte boundary turned on, and there it is in the 16 color palette for the CoCo. Granted, this right now is 404 by 240. The limitation on the image size that you can bring in is 1200 by 1200. But what I can do is I can say, all right, crop this image. And I've got some presets here that are nice for the CoCo values. And let's crop it to 320 by 200. We hit crop. And then if I hit view, obviously, if I do a compile image on this, getting back to your question earlier, Curtis, I can do a compile on that, but the compile size is 72,000 bytes. And we know that that's not going to
It's less than a frame to.
you're not going to be able to load that.
We'll need the gimme X for that one.
You're not going to be able to load that in as a contiguous but I'm like, all right, how can I view this on the CoCo? So that's where dzip comes in. So what I do is I create a dzip of this image. So if I hit view image,
We're gonna see.
and there it is on the CoCo 3.
Glory. That looks great.
So that's how easy it is to bring a full page graphic onto the Color Computer 3. And then what I can do is I can say, all right, if I want to export that as a dzip image or as a compressed image, I can just save this disk image and then I hit load M and execute it, and I've got that image on the Color Computer. And that's what Ron's been playing with. If I come over to tools, I do have the ability to do some dithering. So if I turn Floyd Steinberg dithering on, there's no additional settings on this. Ron has been asking me to possibly come up. He doesn't like the sprite compile stuff. He doesn't like any of all this craziness that's happening all over. He just wants a really nice, clean graphics conversion utility. So what I might do at some point is just do a specific graphics conversion functionality, separate utility, and have different settings for adjusting the dithering and the brightness and all that sort of stuff. And that would be somewhat relatively easy to do based on the work that I've done here. But if I do a paste again with the dithering turned on, you get a little bit different. It looks a little bit better. And again, we can go ahead and we can hit crop.
So when can we see the Apple version?
The Apple version of what?
This tool.
Oh yeah.
As soon as you make it.
So
I'll just be happy with whatever's on Linux.
I mean, Ron could just use GIMP.
Yeah.
These same conversions, but
yeah, again, we'll just pick a different image here. Copy image.
Man, they really like Coke.
I mean, some of these just look kind of cool. So
Must be a sponsor.
yeah, Ron was saying it should be Pepsi, so he must like Pepsi.
I want to drink a soda.
The other thing that it does is like if an image isn't on an even byte boundary, it just gives you this friendly nag that it's going to adjust the image to be divisible on a even byte boundary. So we hit paste. And then what do we got? 356 by 240. If I want, I can go ahead and I can scale the image, and I can go 320. Let's turn off the. And I married these exactly off of GIMP, so that's why they look similar. So you can change what the interpolation looks like. Hit scale, doesn't look too bad. View image, and there it is on the CoCo. Another example of it is this is a pretty cool site that I've often referenced. You take something like Ultima here, and you say, all right, what does that look like on the CoCo? You know, so if I do copy image, we do a paste, and that's 320 by 200 natively. So we hit view image. I still have dithering turned on, so it looks, it'll probably look better if I turn dithering off.
Take that off. Yeah, that'd be interesting to see.
So this was a little bit of feature creep, but I've actually used it quite a bit. And it just makes it nice to be able to do quick and dirty, see what some images look like on the CoCo.
It's really good for any type of graphics conversion, but obviously like title screens and stuff like that. Yeah, that looks really good.
Yep. So let's see, another example of that, what I did with that. One
of my favorites was Gauntlet 2. Yeah, that one's good too.
So I used the sprite compiler pretty much exclusively for this, which is, just kind of like creating a load screen for Legends of Alcaron. I'm not sure if Jay's going to use it. But yeah. And again, sprite compiler to the rescue on this one. Obviously nothing happens after that. And of course I had to create the David Ladd version of it.
Jay liked that one just fine.
Excuse me. Oh, the floppy. Oh yeah.
So the floppy loading version of it. So
no, Jay liked the graphic just fine. I think he was really happy with that. We just have to slap it on the front of that. So
yeah, cool. But yeah, again, you have the ability, to export this as a dzip or as a compressed image to play around with on the. Let's see some other things. There's a palette editor in here if you want. So as you can see, we do have some duplicate values here. So the color conversion always isn't, super precise, but well, let's see what color that is first. So if I do a highlight color on that. So it's that, turn that off. If I want to come in and I want to modify that specific color, let's say we'll do that orangish color, tint yellow, hit apply. If you want to, you have the ability to do that.
So Paul, in this case here, was showing the same code. In this case, do both get used in the image, or is only one being used in the image itself?
Both are being used. So if I actually, what it'll do, and again, what it does is when it brings the colors in, the algorithm doesn't test to see if it's got duplicate colors. That's something I might do at some point, just to remove the duplicate colors. But what's happening is there's two colors that in that 3D RGB space are being matched to the same RGB color in the CoCo 64 color spectrum. So if I do a color distribution on that show palette distribution, you can see that there's 24,130 occurrences of the one and 1742 of the other. And just so you can see the difference between the two. If I turn the highlight on that one, you can see those are just kind of like the edge border colors there. And if I actually turn off the highlight and adjust those, that's probably a better color to adjust. Oops, that's not what I want to do. So yeah, it looks a little bit better. So yeah, so just a little something extra to play with. One other thing, we got 2 minutes. We got actually 90 seconds that I was just reminded of. So if I bring this over and we see the, we'll do the split. So this is a feature that's coming. It's actually in here. I haven't turned it on because I've got to test it. If I do show sprite mask, I see the sprite mask of that single bitmap image. If I hit animate, we see what the mask looks like. If I want to see what the transparency looks like, we can do it that way. But we'll turn the mask back on. I'll pause this for a second. One of the other features that I have in here, I can turn on under general. I want to see what the composite overlay mask looks like. And what the composite overlay mask is it showing you what the mask looks like of all three frames overlaid over the top. So if I animate this guy, the black pixels are pixels that never change. The white pixels are what pixels are active for this particular frame. The gray ones are showing pixels, any pixels that change over time. So you can see that he's kind of walking within that composite mask. What is really nice with this, the reason why I implemented this is I've implemented the ability to do the backup and restore of a dynamic background. So if you have a background, I know that certain people in the community, when they're developing games, they choose to redraw each frame from scratch, each and every frame update. Instead, what I try to do is I like to take the dynamic approach where I've got a buffer reserved in memory for a frame buffer reserved in memory, where I'll do a backup of that area on the graphic screen where the sprite's being written, and then I'll do a stack blast to back up that frame, and then I'll do a restore after I'm done with the sprite image before I draw a new frame. And that gives me the ability to have a dynamic background. There's overhead associated with that. It does take more memory, but it's extremely fast, or has the ability to be extremely fast. Instead of updating the screen each time, you're only updating, the sprite animation each time, each individual sprite frame animation.
Yeah, you're only updating the screen where the sprites are actually going to appear. You're not changing it in a static
exactly
background. Yeah.
What I've done with this latest functionality, Curtis, I've taken it to the next level. I've created an adaptive stack blast method algorithm where what it's doing is it's only backing up the pixels that have changed. So anything in this gray area gets backed up to the stack. The black does not get touched. And the same thing happens when it does the restore. So it'll restore only the pixels that have changed within this gray block and none of the black. So it doesn't yield a benefit every single time. Sometimes it's better to, just to grab the whole frame. But if you've got a particular sprite animation that does have a lot of background to it, it yields an unbelievable benefit. And sometimes, it's 50, 75, 100 times faster, 100% faster. I was showing Paul some examples last night, and it was unbelievable, the difference between the two. That's currently in the tool. It's not turned on in this distribution that I posted to GitHub. I still need to do some more testing with it. For folks that like to, that don't want to have the overhead of keeping a stack blast copy of the background dynamically in memory in that frame buffer, some people, what they do is they keep a backup copy of the background someplace else in another block of memory. You can actually use just the restore functionality and point your buffer, put the pointer for that sprite to that specific location in memory, and it'll take advantage of just pulling the pixels out of that backup copy and restoring those to your active page as well. So you have the ability to take advantage of it in a couple different ways. So that's coming soon.
Yeah, I'm still trying to put
Cool.
my brain back into my head after my mind was blown last night when he showed me this.
Yeah, it's pretty neat. The way that it worked, and what actually blew me away, and I was telling Paulie about this last night. I took a very methodical approach to it. I ran into some issues when I was doing the stack blasting of the sprites initially, because of the way that I was doing the masking and the way that I was adjusting the pointer, the stack pointer for drawing the stack blast sprites. So I took a very methodical approach to this new functionality, and it worked the very first time that I tested it, which was just absolutely blew me away. As complex
That never
as it
happens.
is.
What are you talking about?
No,
Yeah.
it doesn't. And it's just because
Wow.
I just, I spent a few days systematically working through the algorithm, testing it each step of the way. And then it just ended up working, and it blew me away. So it's pretty neat. So that's coming soon.
Yeah, I'm
So-
definitely going to be taking advantage of that.
Okay, well, Mr. Redbeard has a hard out here, and I wanted to try to keep this down to a couple hours. So I think we've got a couple hours in. Hey, Paul Fiscarelli, were we thinking you wanted to show off a little bit more of this, maybe with Ron Delvaux on board, or what do you think?
Yeah, absolutely. Get a little bit deeper into some of the functionality with the full screen graphics and showing how those work. I know that that's something he's very interested in, but
Okay.
yeah, if anybody has any questions, I wasn't keeping an eye on chat, but I'd be more than happy to answer any questions, even if it's offline.
I think we got most of them answered. We've had about 10, 12 people. We got 14 watching right now. And so we've had a few questions that have been brought up. So, but people know how to
Great.
get a hold. If they don't, they can get a hold of us, and we'll keep pointing them your direction. So
Did you share the link, Mark, for people to be able to grab a copy of it?
multiple times, but I'll share it again.
Excellent. Oh, one other thing that I was going to mention, along with the compiler, the sprite compiler, Paulie and I use custom palettes with GIMP, and they're really handy for doing the design work on in GIMP. So there's one for RGB, there's one for CMP. I also included one for the Gimme X. Although I need to verify that it's accurate. I think it's close, but I haven't gone through painstakingly checked all 512 colors to make sure that it's accurate. So, yeah, that's there if folks want to play around with that. But it's if you just go on just do a Google search for importing a GIMP palette, there's a palette folder. You just copy those over, and then when you do an image conversion, you basically select your mode as index, and you bubble in the custom palette, and you can select either CoCo RGB or CoCo CMP, and it'll convert your graphics image to that palette.
Okay, if there's not any other questions at the moment, I guess we'll call that a wrap for now. And at some point in the future, we'll schedule another show. I don't know. I know Ron said he couldn't be here tonight, but some point in the future, not immediately, but ways out, somewhere out.
Yeah.
So.
Honestly, the only reason I don't have more questions, because actually I do, is that I know there's going to be a follow-up show, so I'll save it for that.
Alrighty then.
Well, I think we're done for tonight. We'll call it a wrap. And we have some more stuff coming up on this, plus our regular show and the Game On Challenge on Thursday. So tune in, play, show up. And
yeah, thanks again, guys. I just appreciate you sending the invite, asking me to be on, and having Paulie and I, and
I'm so glad to have both
always
of you.
worked. Yeah, for sure.
Yes,
So.
thank you. I was
Glad you're
kind of
both-
waiting
Great.
to say that.
Okay.